Okay, good morning. It's October 10, 2023. This is Professor David J. Pilos Reyes. Okay, my topic for this morning will be a continuation of college algebra. Okay, and the title of the topic is partial fractions involving linear factors only. For this morning, it will be another solution on how to compute for the coefficients of the partial fraction. Okay, let's proceed. My subject matter for this morning will be college algebra lesson number 86. The title of the topic is partial fractions involving linear factors only. The last time around, I gave you example on partial fraction involving linear factors only. There are only two linear factors under the denominator. For this morning, I will be giving you a more complicated one. Okay? It will now be three linear factors under the denominator. Okay? And the problem is asking what will be the equivalent partial fraction of it. And for this solution, it will be another method on how to compute for the coefficients. Okay, let's proceed. For the example for this morning, find the equivalent partial fraction. We are given the algebraic expression 1 all over the product of three binomials, that is the quantity x plus 4 times x minus 2 times x minus 1, and the problem is asking what will be the equivalent partial fraction of this. Since there are three linear factors under the denominator, okay, no one is repeated. So if we try to bring out the equivalent partial fraction of this, there will be three variables, that is an a, capital letter A. The first linear factor is x plus 4 plus another constant, capital letter B. The second linear factor is x minus the quantity x minus 2 plus the third coefficient will be capital letter C, and the denominator will be the third linear factor, that is a quantity x minus 1. Okay, so if there are three linear factors, there should be three coefficients. Okay, so we must have to compute for the value of A, for the value of B, and for the value of C. This is very important in the solution of the so-called integration by what we call this involving partial fractions. Because sometimes there are problems if we put an integral sign here and we put a dx over here. Okay, we are asked to integrate this one. And without knowing partial fraction, we could not integrate this one. This is a complicated thing already, because if we try to expand this one, this falls under a cubic equation. Okay? And 1 all over a cubic equation, it does not fall on one of the so-called integration formulas. So the only way to solve this one, if it falls, if there is an integral sign, the only solution will be by using partial fraction. Okay, I will remove this one now. So at least we now know where we are using this one later on under the study of integral calculus. That is, if we are given a complicated problem involving involving fraction, okay, the only way to solve this one is to find the equivalent partial fraction of it. Okay, I will now try to remove the integral sign. Okay, let's try to bring out the solution. We will rewrite the given fraction, that is 1 over this quantity here, three binomials. Like what I said, there will be three coefficients, a over x plus 4, b over x minus 2, plus c over x minus 1. Okay, and if we try to simplify this one, on the right hand side, we are to add three fractions with different denominators. Okay, So it is something like this. We can still use the butterfly method, but we must have to cover some portion of the right hand side for us to simplify calculations. Okay? If we try to get the multiplier of A, okay, we cover the denominator of A. So the multiplier of A will be x minus 2 and x minus 1. So this is x minus 2 and x minus 1. And to get the multiplier of B, if we try to simplify the right hand side, we cover its denominator and its multiplier will be x plus 4 and x minus 1. This is x plus 4 and x minus 1. And if we try to get the multiplier of C, okay, we cover its denominator, okay, and the multiplier will be the quantity x plus 4 and x minus 2. So this is x plus 4 and x minus 2. Okay, this is the resulting numerator. The resulting denominator will be the product of each individual of this one. So actually, after multiplying A by this, and B by this, and C by this is all over the product of x plus 4 times x minus 2 times x minus 1. And actually, we can cancel now, right? The operation is multiplication. So what remains will be, it will just be simply like that already. No more denominator. Because we got the common LCD on the right hand side. Right? This A here is this one. This B here is this one. This C here is this one. So no more denominator. The left hand side will just be simply equal to 1. Okay, so this is 1. Meaning the simplification of this after taking the least common denominator, like what I said, if you try to get the multiplier of A, you just cover its denominator, its multiplier will be x minus 2, x minus 1. It's this. Right? So we can remove this one now. So the resulting equation now will be 1 equal to the product of this quantity here, two quantities, B times the quantity x plus 4 x minus 1 plus C times the quantity x plus 4 and x minus 2. And if we try to expand this one, the right hand side, it should be a quadratic equation. Quadratic. Okay? And how many unknowns are we looking for? There are 3. Okay? So if we try the solution the last time around, it will be something like this. If we try to expand this one, and by using the solution the last time around, that is equating coefficient of like terms, we will start with x squared. There will be a resulting equation here involving ABC, and we call that equation number 1. The next value of x will be x to the first. Again, if we try to bring out the coefficients of like terms for both the left and right involving x, there will be equation involving ABC here, and we call that equation number 2. The last part is x to the 0, meaning all pure constant terms for the left and right, we equate it. So there will be an equation here involving ABC, and we call that equation number 3. Okay? The unknowns here are ABC, right? ABC. So we need 3 equations. So to solve for ABC, that's a little bit long, right? You could either use elimination by substitution, okay? But it's a little bit longer because you will try to substitute 2 times. Or if you try to solve for the value of ABC by using determinants, you could do it. But supposing you cannot recall the formula and how to compute the value of ABC using determinants, okay, you're gone, right? So solving equation number 1 and 2 and 3, if we try to use this solution here, okay, a little bit hard, right? Because before we could arrive for the value of ABC, it's a long solution. And there is a simpler solution for that one. The simpler solution for this one is like this. Okay? This will be the alternative shorter solution. Okay? When x is equal to 1, to this equation, when x is equal to 1, This is x minus 1, right? This is x minus 1. So when x is equal to 1, this will become 1 minus 1, right? So this will be 0. This will become 1 minus 1. This will be 0. And this 0 here, you multiply that to b. So when x is equal to 1, b will be 0, right? And when x is equal to 1, this will be 0. 0 times a will be 0. So we could compute for the value of c. Okay, you got it? Because when x is equal to 1, no coefficient of c will become 0. So when x is equal to 1, a will be 0, b will be equal to 0. What will be the value of c? We can now compute for the value of c. So 1 should be equal to a times, this is 0, right? It will now be 0. b multiplied by this one, it will now be 0. Plus c, okay? 1 plus 4 will be 5, okay? And 1 minus 2 will be minus 1. So this is gone, right? So the only unknown now will be c, and c will be negative 1/5. As simple as that one. Okay, you got it, guys? Right. Okay, next one. When x is equal to 2, I place it here, a will be 0, c will be 0, and we could compute for b. When x is equal to 2, this is 2 minus 2, right? So you multiply that to a, so a will be 0. When x is equal to 2 on the c, this will become 2 minus 2. A 0 times c, okay? So when x is equal to 2, c will be 0. A will be 0 also. For the value of b, it will not be 0 because when x is equal to 2, this will become 2 plus 4, it will be 6. And 2 minus 1 is actually 1. So actually, if we try to put the value of x to be equal to 2 here, okay, a will be 0, c will be 0, we could compute for b. So b now, 1 now, the left hand side. Okay, this is 0, a is 0. Okay. The value of c is actually 0. The last part here is 0. Because this will become 0. And for the value of b, it will be b. 2 plus 4 will be 6. And 2 minus 1 will be 1. Okay, this is 0, a is 0, c is 0, or this is gone. This is gone. So b now will be equal to 1 divided by 6. So this is b will be equal to 1/6. Okay. Last one. When x is equal to negative 4, b will be 0, c will be 0, we could compute for a. How is that so? When x is equal to negative 4, this will become negative 4 plus 4. This will be 0, right? You multiply that to b. So when x is equal to negative 4, b will be 0. Right? And when x is equal to negative 4, this will become negative 4 plus 4. This will become 0. You multiply that to c. So when x is equal to negative 4, c will be 0. Right? So we could compute for a. So keeping this value x equal to negative 4, we put it back here. Okay? It should be 1 equal to a. When x is equal to negative 4, this will become negative 4, negative 2, that will be negative 6. Negative 4, negative 1 will be negative 5. Okay? B will be 0 because this will become 0. You multiply that to b, so it will be 0. A number multiplied by 0 will be 0, plus the value c. C will also be 0. This will become negative 4 plus 4, it will be 0. 0 times c, c will be 0. Okay? Or it seems this is gone. So the only unknown will be a will be equal to negative 6, negative 5 is plus 30. So a now will be 1 over 30. Okay? As simple as that one. So the partial equivalent of the given algebraic expression now, that is 1 over x plus 4, x minus 2, x minus 1, is actually equal to a is 1 over 30 over x plus 4. The value b is 1 over 6. 1 over 6 over x minus 2. And the value c is negative 1/5. Negative 1/5 over x minus 1. So this will be our answer. Okay? That's the positive solution if we are solving for 3 unknowns. Because actually we could use this one, but if you are not smart enough or not fast enough, you might not finish the problem. So the simpler solution is this one. Okay? That is, assume a value to eliminate the other two coefficients. Again, assume again another value to eliminate again two values. So actually, when x equal to 1, we eliminate a and b. We could compute for c. When x is equal to 2, we eliminate a, we eliminate c, and we could compute for b. And when x is equal to negative 4, we eliminated b, we eliminated c, and we could compute for a. As simple as that one. Okay? So the final answer will be this. Okay, that's it, guys. This last example is a very good solution compared to the coefficient of equating coefficient of like terms. If there are more than 3 or 3 unknowns, okay? For 2 unknowns is just fine because you are only creating equation number 1 and number 2. It's easier to solve for A and B, right? But if there are 3, okay, the solution will be a little bit longer. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.